So these are the topics of module 2. So you have setting up of simplex method, types of variables, solving by simplex method, that is tabular form, which is already being taught in class. So the topics left are tie breaking in simplex method, which I had sent the YouTube link, which is very easy, and the next two topics are big M method and two-phase method. So let's go through big M method. So take a example, that is minimize z equal to 600x1 plus 500x2. Subject to the constraints are 2x1 plus x2, which is greater than equal to 80. x1 plus 2x2 is greater than equal to 60 for all x1 comma x2 is greater than equal to 0. So the solution is, the step 1 is that standardize the equation, that is 2x1 plus x2. So since it is greater than equal to, so you minus the surplus variable and add artificial variable to it. Okay, so that is equal to 80, and the next constraint will be x1 plus 2x2 minus s2 plus a2 is equal to 60, and the objective function z is equal to 600x1 plus 500x2. Also add the surplus variable, that is 0 into s1 plus 0 into s2, plus also add the artificial variables to the objective functions, and the coefficient of those artificial variables are m. Now m is nothing but the number which is higher than the finite number, that is also called as big M. Okay. So there is a note here, for minimization the objective function coefficient of artificial variable will be positive, that is for a minimization problem the artificial variable, the coefficient of an artificial variable, that will be equal to plus m, whereas for a maximization problem it will be minus m. Okay, that is the difference between maximization and a minimization problem. So the second step is construct a simplex table, that is the similar which you have already studied for simplex method, that is CBI, CJ, basic variables. The same thing is followed here. The only difference is you have to add basic variables, surplus variable plus the artificial variables. Okay, and the coefficient of artificial variables is nothing but m. Okay, then the same steps are followed, that is you have to calculate zj, then cj minus zj. So zj is nothing but m into 2 plus m into 1, so you get 3m. Similarly the second column, m into 1 plus m into 2, so you get 3m. Similar steps are followed to calculate zj. Then you have to calculate cj minus zj, that is nothing but 600 minus 3m, 500 minus 3m, 0 minus m, 0 minus m, m minus m, m minus m. Okay, so you get these as the answers. Then solution is nothing but the values, that is 80 and 60. Okay, now from these values, that is cj minus zj, you have to, so now after calculating cj minus zj, we have to select the most negative value from this table, cj minus zj. So what is this most negative value? So if we consider, firstly we have to see, or we have to check for the condition that cj minus zj greater than equal to 0. This is the main condition for this big M method. If this condition is satisfied, then the solution is said to be optimal solution. But in the problem, this is not, this equation or this values doesn't satisfy this condition, because m is considered as very large number, so it will not satisfy this condition, that is cj minus zj should be greater than equal to 0. So from this table we have to select the most negative value, or the most negative value. Now how to calculate the most negative value? For example, if you take, there are two, that is 600 minus 3m and 500 minus 3m. Now just substitute, take any value for m, that is higher value. For example, you can take m as 1000. So if you substitute this value in this equation, that is if you substitute 1000 in place of m, you get answer as minus 2400. And similarly, if you substitute that same value for the second, that is 500 minus 3m, you get 2000 minus 2500. So from both you get this, that is 500 minus 3m as the most negative value. If you consider, here you had got minus 2400 and here you get 2500. So this is considered as most negative value. So this is taken as the key column. And the same steps are followed which was followed for simplex method, that is from the key column, in order to get the ratio you have to divide the solution by the key column, that is 80 divided by 1 you get 80 and 60 divided by 2 you get 30. And similarly, to get the key row you have to select the least non-negative value from the ratio table. So if you consider from 80 and 30, the least non-negative is 30, that is the minimum value. So you mark this as key row, and this is considered as leaving variable, and x2 is considered as the entering variable, and you have 2 as the key element. Okay. So this was step 3. Now in the step, so the next step is to draw iteration table 1, that is iteration 1. So once when you have a simplex table, from that you will have key column as well as key row. So in order to get the first iteration, you have to divide the key row by the key element. So you will get 1 divided by 2, that is half, 2 divided by 2 it will be 1, 0 divided by 2 will be 0, here minus 1 divided by 2, 0 divided by 2 will be 0, and 1 divided by 2. So you get half, 1, 0, minus half, 0 and minus half. Similarly, that 60 will be divided by 2, you will get 30. In order to get the other elements, you have to follow this formula, that is new value is equal to old value minus key column value into key row value divided by key element. For example, if you consider this one, the old value is 2 and the key column value is 1 into 1. So if you want to change this element, so it will be old value minus corresponding key column into corresponding key row divided by key element. So it is 2 minus 1 into 1 by 2, that is 2 minus half, that will be equal to 3 by 2. So this is the same which was followed by which we had done for simplex table method. The same steps are followed here. So you get the other values. Now after that you have to calculate again the same zj value and cj minus zj value. So once you get cj minus zj value, again you have to find the most negative term or the most negative value. Again similarly, that most negative term is found by using here 350 minus 3m divided by 2 and 250 minus m divided by 2. So from these two, which is the most negative value? So again take any value that is higher value. You can take about 1000 or 10,000. Here I have taken m is equal to 1000. So if you substitute 1000 to these two equations, so you get minus 1150 for this particular equation and minus 250 for this particular equation. So if you consider both, the most negative value is minus 1150. So the equation, corresponding equation is 350 minus 3m by 2. Therefore this is considered as most negative value, and that particular value 350 minus 3m by 2 is considered as the key column. Now once you get the key column, again the similar steps, you have to divide the solution by the key column. That is 50 divided by 3 by 2, you get 100 by 3, which will be equal to 33.33 something. Yeah, then similarly 60 divided by 1 by 2, so you get 30 divided by 1 by 2, you get 60. So from this both, the least negative value, that is the minimum value, is 33.3. so this is again considered as the key row. Okay, after this you have to, so and also you get a key element as 3 by 2. Now check for the condition. The condition is Cj minus Zj values, that is it should be greater than equal to 0. But again this condition doesn't satisfy, so you get negative value. That's why you have to go for iteration 2, that is iteration table 2. Similarly again the same steps are followed here. Again the entering variable is x1, so a1 will be replaced by x1. In the behind step x2, that is a2 was replaced by x2, now a1 will be replaced by x1. So instead of a1 and a2 you write x1 and x2 and the coefficient of that. So coefficient of x1 is 600 and x2 is 500. Again you have to apply the same steps to get table, iteration table 2. Finally again Zj value is found, Cj minus Zj values are found. Finally you get the solution as 100 by 3, 40 by 3. Now if you consider the Cj minus Zj value, here as I have already told you, if you see the values all are positive, and here you have m minus 700 by 3 and m minus 1100 divided by 3. As I have already told you, m is the large number, so obviously these both values will be positive. Now the condition Cj minus Zj greater than equal to 0 is satisfied, so now this is your optimal solution. So the last step is just, so what is the value of x1, that is 100 by 3, and the value of x2 is 40 by 3. You have to substitute these values to the objective function, that is 600 x1 plus 500 x2. So you get 600 into 100 by 3 plus 500 into 40 by 3, you get 26,666. So this is the solution to the particular question, that is by big M method. So this notes will be attached to the end of this video. I'll send the notes, so any doubt you can ask me. So thank you.